All right, everybody, we are going to get started here. So thank you all for being here. It's our May meeting. Technically, it's the last one of this academic year. So we're excited for you guys to have been here and see all these meetings, and we're excited to wrap up this year. Today, we are going to be joined very soon by this physician. He's just running a little behind. Yasir, I don't know if you want to give an introduction to him.
Sure. So yeah, he is actually just coming home from hospital. He should be joining us any moment, but I'll be giving the presentation and he'll just come join along. But yeah, I'm very excited and it's my pleasure to have him accompany us later on. Dr. Julio Latorre. Um, this presentation is heavily inspired by his work, as you'll see later on. And just sorry about me. I'm having a cold, so I'm just recovering. So I might have a hoarse voice a bit. But Dr. Julio Torre, he's an SGU alumni, which many of us here are attending, and he completed his residency at Wyckoff Hospital in New York. And then after his residency, he became a travel team physician, which allows him to basically travel around the US and work. He's traveled from east to west coast across 7 states, more than 11 hospitals, including Wyckoff, which is where I met him again. And it'd be funny because there'd be some times where he'd try to finish rounds early, so he has to catch a flight to go somewhere. So it's pretty interesting. He's a pretty busy man. And then afterwards, he went into UCLA and became a biodesign fellow, achieving his MBA. And then afterwards, he co-founded a C and became the CEO of Aerosol, which is an AI-powered autonomous oxygen therapy platform for enhancing patient outcomes, which is what is going to be partly inspired by the article that I'm presenting today. So the article today will be about the dangers of hyperoxia. This article was published in 2021, along many other articles reviewing how oxygen is currently employed in our guidelines and the treatment options, whether we're actually harming the patients with our liberal use of oxygen. Yeah. Next slide, please. So oxygen, very basic, very obvious. It's important. We all need it to live. We use oxygen to produce ATP as one of the most basic most basic things that we need oxygen for. And oxygen is also used for enzymatic processes. And without it, we die pretty quickly. We suffocate, right? So oxygen is very widely used in many conditions. However, there are some adverse effects that do exist with too much oxygen that we have learned through our basic science here, such as reactive oxygen species and inflammatory processes associated with those reactive oxygen species. Just some definitions before we move on. So hyperoxemia is when the blood partial pressure of oxygen is greater than 100 millimeters of mercury, and hyperoxia is when just an increased tissue oxygenation. There's no specific number or cutoff there. It depends very much on the tissue that's involved that you're examining. So going on to the consequences of hyperoxia. Next slide. So reactive oxygen species. So just a flowchart from the article discussing how oxygenation can lead to some damages. So whenever you have the supplemental oxygen greater than the room air, which is the 21% over there, you have an hyperoxemic state where you have the increased partial pressure of oxygen, increased tissue hyperoxia, and those promote the reactive oxygen species formation. And then these reactive oxygen species, they react with other products such as nitric oxide in the top right of the flow chart, which can reduce the nitric oxide concentration, lowering its vasodilatory properties, which instead leads to vasoconstriction and can lead to decreased perfusion, which can worsen things like the NMI or vasospasms in any strokes, for example. And then in terms of the active oxygen species themselves, they can react with other products and induce nitroactive stress, inflammation, do DNA damage themselves, and uncouple the mitochondrial respiration, leading to a lot of heat generation. And worse outcomes. So these are just some of the pathophysiology like mechanisms explained by the article for the dangers of oxygen. But there's also many that are unknown on how they cause their damage, which we can go over soon. So next slide. So just some examples of oxygen damage is like pulmonary toxicity with if one condition that was discussed was inflammatory pneumonitis, which has like signs and symptoms of a patient who is on oxygen, who will then present with retrosternal chest pain, cough, dyspnea, pulmonary edema, and atelectasis, which were not present before the oxygenation. And then this is, or it could be like a worsening of those conditions, paradoxically, where you want to like treat someone with oxygen and they get worse. So the physiology of this is unclear. It involves like reduced mucociliary clearance, and it's basically been observed in cases where patients or even animal models, mostly with oxygenation that are really high or in hyperbaric oxygen situations. And then there are been some cases as well where the reactive oxygen species do induce some of the ARDS through its pro-inflammatory and cytotoxic effects. And then too much oxygen, when you have like 3 atmospheres of oxygen, which is very high, can lead to death and convulsions. But that's also like not a clear mechanism. And then, but that has been observed like way um, many years, like hundreds of years ago. These were documented as well from dangers of oxygenation. um, so there's also like the reperfusion injury, which is what we'd be normally normally hearing is like where you have hypoxia and then you reintroduce oxygen. That leads to that can sometimes worse than the initial ischemic event because in the ischemic tissue you have the acidified environment, which would, if you remember the oxygen dissociation curve, that would cause right shifts, promoting more oxygen release, which is good. You're getting oxygen off, but then you're also offloading too much oxygen in those states, which can promote the reactive oxygen species, and just like in those mechanisms earlier, can induce a lot more damage. And then some vasoconstriction as well as the consequences, because our tissues of high oxygenation sometimes will vasoconstrict to shift that oxygen away to other tissues, but then those have also been observed in our cerebral and coronary vessels, which we don't want to do, especially in someone we're trading oxygen with who is following a MI or a stroke, for example, where we don't want to induce vasoconstriction, but sometimes that can occur. And then later on this article, if you go to the next slide, they go through different. So this is a review article. So what they did was they brought up different patient populations of where oxygenation has been studied, and then they saw the outcomes of these studies. So the first one is the oxygen ICU trial, which was obviously in ICU patients. And then I can pull up the article here beside me. It was in what was it, the year 2016, I believe, and it was a randomized controlled trial with about 480 patients, where 2/3 were mechanically ventilated baseline, 1/3 of them had shock, and the illness acuity was relatively low. And then they compared um, conservative and conventional or liberal oxygen administration, and their definitions for that, when I pull up the article, was a liberal or the standard practice, for example, is what they sometimes refer to that as, is when they allow partial pressures of oxygen to reach up to 150 millimeters of mercury, or the SpO2 between 97 and 100%. Whereas the conservatives, conservative oxygenation protocol is between 94 to 98%, or maintaining the PaO2 between 70 and 100 millimeters of mercury. So not achieving that hyperoxemic states, basically. And then they did like a preliminary analysis of the data they've collected so far. So the trial wasn't fully completed because it was stopped early because of the results that you see here. So they found that the mortality difference was very significant, with a 20.2% in the conventional and 11.6 in the conservative therapy. And that led to an unplanned early termination of the trial. And then they suggested that future trials we obviously conducted in a multi-center and to evaluate the benefit of this approach. And this scared a lot of physicians at the time with oxygenation. And then another trial came out later on the next slide, which is the ICU Rocks trial. This was in 2019. And they, one sec. Okay. Okay. The ICU Rocks trial in 2019 was conducted, and that relieved some of the stress because they showed that the conservative therapy did not significantly alter the number of days alive compared to the liberal or conventional oxygen therapy. And then their results were overall as 29.7% to 32.2% mortality. So their conclusion was that it did not significantly affect the number of ventilator-free days, and so it's still very confusing as to what oxygen guidelines should be employed. So for the ICU specific patients, the guideline that I found was that you should avoid, like you should very much avoid greater than 300 millimeters of mercury for your PaO2. Um, and that's for that population. So then this article discusses other populations as well, for example, the septic shock patients. So theoretically, like hyperoxia, sometimes, as I discussed, that can help vasoconstrict. But then this study over here, the Hyper 2S, which stands for the hyperoxia and hypertonic saline in patients with septic shock, is a randomized control trial. It compared standard therapy versus 100% oxygen for the first 24 hours after diagnosing someone with septic shock. And then the SOFA score, which is a sequential organ failure assessment score, was lower in the hyperoxic patients after 7 days. However, mortality was increased in patients receiving 100% oxygen, like we just put someone on oxygen and like the liberal oxygen use, as I mentioned earlier, and that mortality was increased in day 28, day 90 in the hyperoxia group. And this again led to a premature stoppage of the trial where they published their results. And then their interpretation of the article was that in patients with septic shock, setting the FiO2 to 100% to induce arterial hyperoxia might increase the risk of mortality. And then also this article was looking at hypertonic saline, and they say that hypertonic saline did not improve survival as well. And this article was in 2017. So the next population this review assessed was patients with brain injury and hemorrhage patients. And then you'll find this me saying this over and over again. It's unclear having a set point. There is some damage, and some articles say there isn't any damage. So in brain injury patients, it was unclear whether normal oxemia or a targeted hyperoxemia influences brain function and the neurological recovery in some articles. And then it's unknown what the optimal targets based on like patient populations and what type of brain injury treating and things like that would affect our oxygen use. The doctor just texted me saying he'll be on in about 5 minutes. Okay. Um, Next patient population was the hemorrhage patients. Oh, okay. So basically, again, you want to get oxygen. If someone's hemorrhaging, they're going to be losing a lot of the oxygen transport. So if you pump a lot of oxygen into the blood, that should help. However, articles again were unclear, inconclusive with the specific PaO2 levels, mortality associated with that as well. So there's a lot of unclear, again, guidelines with how much oxygenation and things like that. And then I think the last study group I have included were the cardiac arrest patients, or second last one, sorry. And then these patients here, the cardiac arrest, the current guidelines is to have 100% oxygen during CPR, but then there's no study that assessed if you should lower that, and I'm not sure the ethics of getting a study set up that to study that, how that would work. But then during cardiac arrest, obviously your brain tissue oxygenation decreases very rapidly, and then CPR has been shown to increase this oxygenation. And then observational studies show that the higher PaO2 would correlate with increased likelihood of return of spontaneous circulation, survival, and outcomes. But then other randomized studies and trials analysis show conflicting results. So again, it's unclear. So the recommendation generally is to have normoxemia preferable, and try to avoid hyperoxemia. But it's very important to avoid hypoxemia, as that's the most deadly of them, of course. Um, so again, very unclear to have a specific set of guidelines. And then the last population studied was the perioperative patients, which were patients obviously around surgery. So some theories right now were that hyperoxia can help prevent wound infections. High fractional oxygen inspiration could, however, lead to resorption atelectasis, which could exacerbate VQ mismatch. So again, there's our benefits and adverse effects. You got to balance them, and so the most evidence suggests to the greatest safety is again to try to maintain normoxemia um, with regards to their oxygenation. So in summary, for ICU patients, you should avoid that greater than 300 millimeters of mercury. But the targets for the PaO2 and the titration are unclear for many conditions. So this has been an active area of research. And there's a big upcoming trial coming up called the MEGAROX, which is the mega randomized registry trial comparing conservative versus liberal oxygenation. And it's still, it hasn't been completed yet, but then the target is about 40,000 patients with the outcome to provide ideal PaO2 targets for a variety of conditions. And the hypothesis that they presume for the benefit of conducting this research would be that the conservative uh, oxygenation they came up with the value of reducing mortality by 1.5%. So it's about saving 1,500 lives for every 100,000 of patients uh, that we would switch to using conservative oxygenation for. And then the YouTube video there is just promoting that trial as well and giving some background information. It's a 13-minute video, which you can watch on your own if you're interested in that. So that is the article. It is a lot about oxygenation and it's unclear about guidelines, but this is just a review article. So it reviewed many of the different um, pathologies and whether oxygenation was shown to help or not, and it helps set up a uh, area where we're lacking in research. So it's very clear that we need more research on oxygenation in patients, what guidelines, what cutoffs, and how much, how long they should be using. But it's very hard to track all that. So this is where Dr. Julio Latorre was very interested in this, and he decided to found this company called Aerosolve. So Aerosolve, I had hoped he'd be here by now, but it looks like he hasn't joined, right? No, okay. um, so Aerosolve was the
He
AI-powered
just showed up.
autonomous. Sorry.
He just showed up.
Oh, you here? Oh, hi, Dr. Julio. Um, so I just went through the review article to get you caught up to speed, discussing hyperoxemia, and um, we discussed the dangers of hyperoxemia, and then what's lacking, and then how your company, which you're founded, should help us eventually come to solve these issues. So Aerosolve, just briefly, through the slide. So oxygen management has been stagnant for a century, leading to excessive oxygen resource waste and disconnected patient data. So Aerosolve aims to solve this problem with a fully automated hardware software platform, optimizing oxygen therapy, enhancing patient outcomes, introducing waste through a closed loop system integration. And then the goal through Aerosolve is to pioneer clinical trials for hospitalized patients. And then the Aerosolve was spun out of a UCL biodesign program, which I discussed earlier, where he completed his MBA, and he's currently doing 2 studies in New York, Brooklyn Hospital and Wyckoff Hospital, I believe. So further that I have, if I can share my screen for a moment.
Go ahead.
Thank you.
Do you want me to just do the pitch, like go over this company very quick?
Oh, sure, you can do it. Yeah.
Can I share screen? Let me just make sure.
You should be able to share your screen.
Let me just try to get the. Oh. Oh, why can't I find this now?
I could pull it up if you'd like.
Yeah, but I want to be able to control it, and I think there might be some. See, you know what? I could probably just look it up on the PowerPoint too. That's not it. No, I can't get to presentation mode from here. Let's try one more thing. Oh, this. Okay, I think I got what I needed. Let me just make sure this is. Okay. Cool. Okay. Let me just. Turn this off. All right, let me share the screen now. Can y'all see this?
Mhm.
Which screen are you seeing? The PowerPoint?
Yeah, we see the PowerPoint.
Okay. And we'll start here. Okay. So I don't know. So my name is Dr. Latore. I am a physician, hospitalist, SGU grad. I think I graduated in 2016. Did residency at Wyckoff Hospital and have now spent the last 2 years working on my company, Aerosolve, which we are doing essentially a fully autonomous AI-driven oxygen therapy. I didn't see Yasser's presentation, but I'm sure he kind of went over the dangers of hypoxia, but just going to give you a little quick insight into what we're doing. So why does it keep? Oh, I know what happened. Okay. So anyways, oxygen is one of the most common medical therapies given to about 50% of hospitalized patients, patients from CHF, pneumonia, COPD. 100% of post-surgical patients get this, not to mention patients on home oxygen who get this at LTACs and nursing homes and their actual homes. So you may be surprised, but the process of oxygen has not changed in over a century. It's still just this manual trial and error process. I know you're medical students, but I'm sure you've probably seen this. It's just essentially you get a reading, you titrate, and it's just very, very time consuming. And this is kind of what this slide kind of gets to right there. This is a very, very time consuming process. So nurses only get to it once per day. And studies are showing that patients end up getting too much oxygen 84% of the time. Which to most people, that sounds good, right? You're physicians, so you probably, but even most physicians are not really aware. I have to present this to investors, and PhDs and everything, and they all kind of have this positive association with oxygen, right? What's the problem with patients getting too much oxygen? Well, it's deadly. Like number one, it's just very, very bad, and there's like a lot of studies that show this. So a very landmark study in the Lancet journal It was of 16,000 patients. A meta-analysis showed that patients who received too much oxygen were at a 21% increased risk of death compared to those who weren't. Those are patients with sepsis, all-cause mortality, sepsis, stroke, MI, everything. The risk was even more dire when it came to patients with COPD, as the risk of death was increased by twofold, which you're probably a lot more familiar with that, as I'm sure you learned the mechanism of that in your physiology classes. But that's not where the problem ends. The issue too is that you just get inadequate monitoring, right? So you're probably not aware of this, but if a patient's getting oxygen, they might be on 4 liters. They might stay on 4 liters all day despite having an improvement of their clinical course. And as a physician, I want to know, how are they improving with time? And I usually just don't get that. So I get inadequate monitoring, that delays treatment, and it prolongs hospital stays. And finally, we just waste a lot of oxygen, which as a commodity. And this can be bad, especially when it comes to crisis situations. We see in COVID, this became an issue, also during earthquakes and hurricanes like that. So yeah, here's a quick look at our solution. We're doing, just like I said, fully automated oxygen therapy. It's a device software platform that's essentially going to do continuous monitoring for patients. That continuous monitoring is going to provide continuous adjustment, so patients are always getting the right amount. And it's going to provide insights for providers. It's going to integrate easily into the hospital infrastructure. So you can kind of see, basically, it's a device that's going to hook up to the flow meter. It's going to take data directly from the vitals monitor. So you're going to get all that data from respiratory rate, SpO2, waveforms. It's analyzing all of that. A physician will set their desired oxygen saturation range. And from there, the device is going to just continuously adjust the flow of oxygen so that the patient is always on the right amount. This is the value proposition. I'm not going to go too much into here, but improve patient safety, decrease length of stay, decrease oxygen utilization, improve nursing workflows as well. Nurses are already overburdened, so this is just kind of like one less task that we have to burden them with. So, and I'll get into this one: improve clinical decision making. So what's great about this invention is it's a very, very true closed loop system that you really don't see in healthcare today. So we're getting like real-time data directly from the patient, and we're doing an intervention. In this case, the intervention is how much the titration of the oxygen. We're doing that intervention, and we're actually getting an outcome. We're trying to see what oxygen are they on, right? So theoretically, in real time, you're able to see like their their disease response, right? You're able to see a patient respond better in real time, just based off that oxygen flow measurement, right? And this can work for a lot of different use cases. I think this is probably going to be a metric for a lot of stuff like CHF, pneumonia, COPD, pulmonary embolism. And so yeah, a very, very true closed loop system that you really don't see in medicine, which gets us a lot of very, very valuable data. One of the things that we're trying to pioneer, and I don't really have it here, but like I said, we're going to have really, really valuable data, is like getting what I call in-demand clinical trials. All right. So every day as we speak in hospitals around the world, tens of thousands of clinical trials are going on, but we're not capturing that data. All right. It's very, just like I said, the data is disaggregated. You're not getting the data in real time. In this particular case, we're going to be able to get that, right? We're getting the oxygen flow data. We're getting, just a ton of patients' data. And we're getting their like real-time response. So you'll be able to see, once this eventually scales to thousands of patients, millions of patients, let's say like you want to test, okay, how did a 55-year-old with COPD, with community-acquired pneumonia respond to X antibiotic, right? Which one? And then you'd be able to do that. And you'd be able to like get, a cohort of, 50 patients, 100 patients. So it's going to be very, very valuable, I think, with regards to that, because data, as you know, like when it comes to machine learning and everything is really just everything right now. And it's going to be able to tell us a lot about patient care and really improve patient care in the future. This is the market opportunity. Not going to go much on this. So we already filed our patents. We have a fully working prototype. We've done extensive market validation. I did an extensive data analysis at UCLA Health, and we're currently doing pilot studies right now at Wyckoff Hospital, Brooklyn Hospital Center, and then the Cleveland Clinic soon. This is like a little picture of our prototype, which has changed a little bit since then, but you get the idea. This is the team. So like I said, I already introduced myself. My other team member is Nico Vansnick. He is the former founder and CEO of Bot Factory and a robotics engineer. He led the company for over 10 years and exited it. And Alfredo is working on the machine learning. He did his BS in physics and mathematics at Harvard and his MS in financial engineering at MIT. He works on machine learning when it comes to, for a hedge fund, essentially predicting the movement of stock. So he's used to seeing lots and lots of data and doing whatever manipulation or analysis of it at very high stakes. This is our advisory board. I'm not going to go too much into this, but timeline and yeah. We are, and I should just kind of start this. We are going to be doing a study. We have a study right now at Brooklyn Hospital Center, but this one's going to be at Wyckoff. So this particular case is going to be for patients in the PACU. So I'm not sure what you're familiar with the PACU, but the PACU is where patients go after they get surgery. You know, all of them are on oxygen. They're sedated. They just had, you know, their anesthesia. And you go there and you wait until, you know, you wake up and then you're able to get off of oxygen. So it's a really good environment for us because it's a very dynamic environment. You know, all of them are on oxygen, all of them end up off oxygen. So we're able to kind of see that that story kind of like play out in real time. It's really good for getting training data for our machine learning. And yeah, so the little bit about the study, we're essentially using it to collect data to compare it our AI, which we're going to do that next year. But for this particular study, we're just going to assess the efficacy of standard oxygen therapy in post-operative patients. We're going to categorize them by having abnormal lung function, so CHF, COPD, OSA, and then normal. And then we're going to see how often was this patient on oxygen, how long were they in the hyperoxemia range, how long were they in the hypoxemia range. We're going to see their outcomes, right? So like how long did they stay in the hospital? Were there any complications? And then, yeah, and just kind of see what happens. So I put 50 patients, but I think now the goal is to do 100 patients in the matter of a couple months. And yeah, we're using our device to collect all that data I was telling you about. So I'm presenting to the IRB next month to do this. So if anybody is interested. But with that, I will leave you with if anyone has any questions, I'm happy to answer.
I did have a question, but it seems like this trial type is kind of answering my question a little bit. Is that it seemed in the presentation, it seemed like it was more geared towards maybe tele or floor patients versus like ICU patients or something like that. But now you're saying you're doing this trial in the PACU. So it seems like we're trying to see if we can apply this in as many parts of the hospital as possible.
Yeah, exactly. So just, you know, because I mean, look, I'm a hospitalist, so I'm kind of biased towards the floor. So that's what I did. That's what our initial study was. And also just doing studies on the floor is a really big pain in the ass. You have to get the patient recruitment. You don't know what floor they're going to go to. Some nurses are not going to be down with this. And in the PACU, it's really easy. I mean, I made friends with the whole PACU team. The chief of anesthesia, Andrew Lau, is really cool. He really into the study. So like they're all on board. And the good thing about the PACU too is that there's 10, you know, you could have 5-10 patients in there at once. And theoretically, I could be testing all of them, you know, within a matter of hours. So, you know, 5-10 patients, as long as I have the devices. So we're making more devices right now. So, but yeah, it's a different use case. It's a big market as well. It's basically everybody that goes through surgery. So from a business perspective, it works as well. And there's a lot of complications too. Like when it comes to one of the big things that I didn't know, but the anesthesiologist told me was that they really want to assess the like the different anesthetics, like on respiratory function. There's been no studies. So like, you know, you use, you know, halothane versus this. You know, this one for COPD might not be good because this might suppress the respiratory drive longer. And those are the kind of like findings that we're trying to look for.
Very cool. I'm starting a surgery residency at Wyckoff in about a month. So
so you'll probably interact with this.
Yes, yeah, definitely interested to keep following up.
Yeah. Anyone else have any questions?
Yasir gave a little intro about you at the very beginning and mentioned that you did some like traveling work. Could you talk a little bit about that? Like I've never really heard of this before.
Oh yeah, so during the pandemic, so I graduated 2019, And then, you know, obviously we know what happened in 2020. And I was living in New York City and like kind of everything was shut down. So I got this offer to work for this travel team. And it was really good money because the hospitals needed doctors, you know, especially like in these rural areas. And you know, they pay for your flights and hotels and all that, and everything was shut down. So it was good. I did it I still do it every once in a while. I might travel, I might work like 1 week every few months. Like I have a relationship with the company, but I don't, you know, it's not a full-time thing anymore. So just here that you already did you did your thing with the article.
Yeah,
whole thing?
we reviewed the article, yeah.
Yeah. Yeah, one of the things about I guess like the points of that article as well too is that we just don't know like what is the proper oxygen range for patients, right? Because every patient's different, right? What if it, you know, it could be different for SEPT. We know what it is for COPD, right? Like y'all probably know that, right? COPD, the 88 to 92%, we have that range. That's kind of set in stone. But you know, there's a host of other diseases, and we don't really know, and it's really, really, really hard to test. And I suspect is that, you know, most people don't know, but oxygen is a drug, right? Just whatever you say it is, it's a drug, right? It has toxic effects, it has therapeutic effects, but it's not dosed like a drug. We just kind of like throw it at people, and we don't do that with any other drug. So one of the things that like what I'm trying to do with this platform is that to be able to figure out like, wait, what's the best response for every patient? Because you know, one of the things we're doing is that we're going to let every doctor say, hey, you know, and you speak to multiple doctors, like some doctors want their patients to be at 100%, some of them want to be at 95%, 96%. You scale that out, you know, to hundreds of thousands of patients, we'll start seeing what actually works for what diseases. But yeah, right now we know it's probably, you know, it's not good if you do too much for most patients, but you know, there could be specific conditions where it might be, you know, useful. But like I said, we have to do the studies to do it. So
We did just get a question in the chat. Someone said that they wanted to know, have these been implemented in hospitals already? They said, I think this could have been such a huge impact. This could have a huge impact in hospitals, especially after seeing how it's mismanaged while they were in their IM rotation.
exactly. No, and we hope to be the first ones implemented. It's not implemented. We're in the process of doing that now. Unfortunately, you have you know, regulating bodies, and by that I mean the FDA, that we are dealing with right now. We have you know, we have to show, you know, some efficacy, we have to show safety, most importantly. And what's really tough about this product is that there really is nothing, there's no precedence for this. So, you know, they know how to, there's, you know, certain medical devices that, you know, you test it, we know, but this is like an AI medical device that's actually doing an intervention. So it's actually deciding, hey, you know, this patient should get this much oxygen, or should it not? And it's, you know, since it's AI, it's changing all the time, right? Once you get new data, you update your models. So it's very tough, right? So, and I'm not, I mean, there's other companies that are doing some, you know, doing AI medical devices, but it's a long road. We have a lot of money on lawyers and FDA consultants right now, and no one really knows what the hell's going on. So, you know, we hope to get this in the market probably, my best guess would probably be like, you know, best case scenario will probably be 2 or 3 years.
All right, are there any other questions for the doctor or Yasir? All right. Well, thank you both.
Cool. Thank you guys.
Thank
you,
you so
Dr.
much.
Julio.
Thank
Yeah.
you.
And feel free to email me if you have any questions.
All right, everybody, we will start to transition over to the last half of the meeting. As usual, it shouldn't be super long. Let me get my screen back up here.
So Dr. Julio, you're free to leave the meeting, and then we'll just continue, as I said, on our group's meeting.